All right, welcome back. We are going to be looking at ellipse today. Okay, we're looking at 10.3 ellipse. So how is this ellipse formed? Well, recall we have this generator here for the double napped cones, and then we have a plane that intersects the cone here, and this plane you can see is tilted. Yesterday was for the circle, or not yesterday. Uh, well, yesterday for me. There was a plane that intersects the cone horizontally, right? So it forms a circle. Now this is tilted at an angle that is less than the generator, okay? If it's less than generator, you can see here, this is the ellipse that it's formed, okay? So again, when the plane intersects the cone at an angle that is less than or less steep than the generator, then an ellipse is formed. So in general, you can think of an ellipse as a stretched, that's not how you spell stretched circle. Okay, now as a, or in terms, oh, that's not bad. Okay, so here we go. This is an ellipse. Okay, it looks like this. Okay, now I put the two dots there. Now it looks like an uh, alien, ET. I don't know. Okay, anyways, it looks like a face. It's kind of cute. This is what we call a focus. Okay, this point is what we call a focus. When we have two focus, we call it's plural, so we call these are foci. Okay, the foci. Okay, so an ellipse is formed when we have these two foci and the point on the ellipse. Okay, so the points on the ellipse are a set of points whose sum of distances from the foci is constant. Okay, you might ask, well, what does that mean? Okay, so let me show you what that means. Okay, so let's say I have a point on the ellipse. Okay, so here's a point. Okay, this is one of the points on the ellipse. I'm gonna draw two straight lines to the foci. Okay, from that point. Okay, and there's my P1, and let me call this D1 and D2. So D1 plus D2 would then, okay, let me pick another point. Let's say here. Let's pick this point here. There's my P2, and there is my D3, and then there is my D4. So these two, okay, the sum of D1 and D2 would be the same as D3 plus D4, okay, because they are both they're both the points on the ellipse. So their sum of distances from those 2 points respectively to the foci should be the same. Okay, so you can pick another point, I don't know, somewhere here, let's say maybe in the middle. Okay, here's my P3, and again you can draw two direct lines from the point to the foci. So this would be D5, and then here's D6. And again, the sum of D5 and D6 would be the same as D1 plus D2 and D3 plus D4. Okay, so that's what it means to have an ellipse. Okay. Now, from the equation perspective, here is the equation of an ellipse. Okay, in standard form. This is quite similar to what we have yesterday, or again for me it's yesterday. I don't know about you, but this was the equation for the circle, right? It's x minus h squared plus y minus k squared equals to r squared. So it's quite similar, except that now we are making equal to 1. Okay, so really, if you just divide both sides by r squared, then you end up with x minus h squared plus y minus k squared equals 1, but now over r squared and r squared. The only difference is that in ellipse, a and b are not the same, or a squared and b squared are not the same. Okay, if they were the same, then it's really just a circle. They are not the same. And That's why we call an ellipse the stretched circle. Because recall from transformation unit, the a squared really is just the horizontal expansion or compression factor. Okay, and b squared, same thing. It's just the expansion or compression factor vertically because it's with y. So this, and recall, this is a plus, and this is a plus because it's the sum of distances, right? It's the sum. Okay. Anyways, this will be a horizontal ellipse if a squared is bigger than b squared, because it means that it's stretched more horizontally, right? Because a squared is bigger. It will be a vertical ellipse if b squared is bigger than a squared. Again, that means because it's stretched more vertically, so then it's a vertical ellipse. Okay, so hopefully that makes sense to you. Okay, so that's the standard form of an ellipse. Let's now take a look at this example here, and then let's do it. Okay, let's actually graph it. So we have an equation 9 times x minus 4 squared plus 4 times y plus 1 squared equals 36. This is actually quite close to standard form already. All we needed to do is just to divide both sides by 36. So let me copy down the equation first. And then I'm going to divide both sides by 36. So then you end up with x minus 4 squared over 4 plus y plus 1 squared over 9 equals 1. Okay, so the way to figure out the center of an ellipse is actually the same thing. Okay, I don't even know if you call this the center now. I don't know. Anyways, I guess it is. Okay, the center of the ellipse will be 4 comma negative 1. So 4 comma negative 1 is right here. Okay, and now we can figure out, okay, so recall from last lesson for the circle, once we figure out the center, we can then look at the radius and then we just go, x units to the right, left, up, and down. Well, we're going to do something similar for ellipse, okay? Except that we don't go right, left, up, and down, all the same units, okay? The right and left will be the same because it's horizontal stretch. Up and down will be the same as well, but horizontally and vertically will be different, okay? And how do we figure that out? Well, that comes from a squared. A squared is 4, this means a is 2. B squared is 9, this means b is 3. Okay, that means we are going to stretch, well, I guess we're going to go 2 units to the right from the center and 2 units to the left from the center, okay, because a is 2 and that is with x. We're going to go 3 units up from the center, 1, 2, 3, and then 3 units down from the center, 1, 2, 3. And there is our ellipse. Okay, let's see if I can draw this nicely here. Okay. Respectable. I guess this piece is not as good, but it's okay. It's not that bad. Approved. Approved by myself. Okay. Little sad. That's okay. Domain. I'm going to write in interval notation today. Domain goes from 2 to 6. And range goes from, so -4 bottom to top, so -4 to 2. Okay, and we are also looking at the directions and length of the major and minor axes. Okay, so major axis, or axes, I guess, major and minor axes. Major axis is, in this case, vertical. Okay, you can see it's stretched more vertically, so this is vertical ellipse with length. Vertical 6. Right? You can see b is 3, so really just 3 up and 3 down, so just twice that, so length is 6. Minor axis would be horizontal with length of 4, because a is 2, so 2 to the right and 2 to the left. Okay, so that's how you do this in standard form. And you probably can see this coming, right? Equation is not always given to us in standard form. In fact, it usually is not, right? Usually it's given to us in general form. Okay, so this is quite similar to a circle equation for general form. Well, because, I mean, if the standard form is similar, I'm assuming general form will be similar too. The only difference is that this part right here. Or the biggest difference is that A cannot equal to B. And of course, it cannot equal to 0, okay? So for circle, it just says that A equals B and that they cannot equal to 0. In this case, A cannot equal to B. If A equals to B, then it's a circle. Okay, and also that both A and B must be bigger than 0. Okay, so here we go. Here is the equation in general form. You probably could have guessed it as well. To graph this, we will need to turn this into standard form. Okay, so we need to complete a square for both x and y. So recall what we need to do first is to collect, not like terms, but we group the x's and the y's together separately. Okay, so 16y squared with 32y. I'm going to keep the minus 159 on the left hand side today for now. It doesn't really matter, okay? I mean, at the end of the day, it's the same thing. Okay, now I need to factor out 25. So you get x squared minus 8x divided by 2 is 4. 4 squared is 16, so plus 16 minus 16 plus 16. Y squared plus 2y divided by 2 is 1. 1 squared is 1. Minus 159 equal to 0. And now I'm going to factor this, right? Because that's a perfect square. That's x minus 4 squared. I'll deal with the negative 16 in a second. This is a perfect square. That's y plus 1 squared. Okay, now I need to take this negative 16 and negative 1 out by multiplying by the coefficient in the front. So 25 times negative 16 is 400? Yeah, 400. So wait a second. Is this right? Oh my goodness. Oh my goodness. Okay. I knew it's wrong. Okay. Here we go. Once again, I made a mistake, as always. Okay, it's plus 9 minus 9 here. Sorry about that. So now, 25 times negative 9 is negative 225. Minus 16 minus 159 equals 0. We can move these three terms to the right. You should get, I believe, 175. Yeah, 400. So plus 16 y plus 1 squared equals 400. Now this looks much better. Okay, now you can divide both sides by 400. You then get x minus 3 squared over 16 plus y plus 1 squared over 25 equals 1. Perfect. There we have our center, 3, comma, negative 1. Okay, center is 3, comma, negative 1. A squared is 16, which means A is 4. B squared is 25. That means B is 5. Okay, and now we can actually find or get some points. So A is 4, so we're gonna go to the right 4 units and 4 units left. B is 5, so we're gonna go up 5 and down 5. Okay, let's see if I can draw an ellipse nicely this time here. Okay. Okay, well, you get my point, okay? It's acceptable. Okay, I think the previous one was better. Okay, anyways, so there's our graph. We can find the domain and range quite easily. Again, once we have the graph, it's easy, right? Domain is negative 1 to 7, and range goes from negative 6 to 4. Okay, perfect. Major axis, this time again, it's still vertical, major axis. And with length of 2 times b, which is 10. Minor axis, well, if major axis is vertical, then I guess minor axis will be horizontal. Horizontal with length, again, 2 times, in this case, a, is going to be 8. Okay. Hopefully, it's not that bad. Okay. Again, it's similar to what we did for circle. It's just slightly different. Okay, not much because of the stretch factor. Okay, there's a practice question for you to do. Good luck, and I'll show you the solution a bit. All right, so hopefully you factor out the value of b out first, just like in transformation. Okay, this is 2x minus 4, and that's 5y minus 10. So make sure you factor out the value of 2 first. Squared plus 5, and then y plus 2 squared equals 100. So then you get 4 times x minus 2 squared plus 25 y plus 2 squared equals 100. Okay, so be really, really careful. If this is factorable, make sure you factor it, because again, standard form says it's x minus h, y minus k, not 2x minus h or 2y minus k or 5y, whatever, right? Okay, now we can divide both sides by 100, then you get x minus 2 squared over 25 plus y plus 2 squared over 4 equals 1. So then we have our center. Center is going to be at 2 comma negative 2. So 2 and negative 2 is right here. We have a equals 5. Hopefully you can get that by looking at this, right? A squared is 25, therefore A is 5. B squared is 4, so B is 2. So we're going to, from the center, we're going to go 5 units right and 5 units left. And then we're going to go 2 units up and 2 units down. Okay, now let's see if I can draw this horizontal ellipse beautifully this time. Okay, I don't know, where should I start? I'll start here again. Oh my goodness, oh man, it's pretty ugly, hey? Okay, I got no talent in drawing. You probably know that by now. Okay, so there you go. Okay, so we have domain and range would be domain goes from -3 all the way to 7. Oops, 7, and range goes from -4 to 0. -4 to 0. We have major axis, which is horizontally, right? It's horizontal. And length is going to be 2 times a in this case, 10. Minor axis, then it's going to be vertical, and that will be with length of 4, 2 times b. Okay, so that is it for today for ellipse. Hopefully this is not too bad. Again, it's similar to circle. It just, again, stretched both horizontally and vertically. Okay, there's some practice questions for you to do. Let me know if you need some help. Otherwise, that's it. Good luck. See ya.